Right. So good morning, everyone, and welcome to Physics 124-103 Biophysical Principles. I was very much looking forward to meeting all of you in person in the lecture theater on campus, but yeah, unfortunately, we had to move the lessons online. But this is just temporary, just until we're at the red alert level. Once the cases start settling down, then we can go to live lectures face to face in the classroom. So I'm still looking forward to meeting all of you in person, but for now, we'll interact online virtually. Let me just share my screen. Right. So that's showing okay? Some thumbs up to let me know you can see the screen. Yeah, thank you for confirming that looks okay. Right, so just before we start, I'll give a little bit of introduction about myself and about the course. And yeah, so my name is Mary Lou Raduban. My first name is Mary Lou. You can just call me Mary Lou. I'm the Albany course coordinator, and I'll be your lecturer for the whole semester. I'll be teaching the lectures and the workshops. I'll be helping you with the labs as well. If you go to in-person labs, you can contact me through various means. So at the moment, the best way to contact me is through email. This is my email address, which you can also find on stream. My office is at the Watson Science Labs, at the physics labs, where the student central is located, where the cafeterias are. I'm going to my office, so if you'd prefer like a face-to-face meeting, we can arrange that as well, of course, with appropriate social distancing and following the guidelines of the university. My office hours, I would say the best way would be to set an appointment. So contact me by email, and then we'll set an appointment that's convenient for you and for me, and yeah, we can go from there. So I would say the best way to contact me is through email. I respond to emails rather quickly, even at night or the weekends. So yeah, feel free to contact me anytime. The overall course coordinator for this course is Tony Signal. Tony, he's based at Palmerston North. You've probably seen his messages on stream, or his first video with the first lab. So your first point of contact will be me as the Albany course coordinator, and then if we cannot resolve any issues, we'll go to Tony. But yeah, but shouldn't be a problem resolving the issues at Albany level. Right. Yeah, if you have any questions, by the way, just feel free to raise your hand or interrupt me. You can also use the chat box to type in your questions or comments. I'm keeping an eye on the chat box as well. Right, so so we will run the course as we would run in the normal settings. So we'll still follow the timetable. We have 2 timetabled lectures. One is now, Wednesdays 9 to 10 and Fridays 10 to 11, and two workshops per week, which follow immediately after the lectures. The only difference is we're running these online, okay, but we're still following the timetable. We'll still do the labs. You still have 1 lab every fortnight. The only difference is because we cannot run face-to-face labs, you will be doing the labs in distance mode, and you'll have 1 laboratory homework that's due every fortnight. And to support you with that, we've prepared some videos there. The first video for the first lab is now posted on stream. So you can watch the video to have some guidance about what to do in the first lab homework. The first lab homework is not due until the 3rd week, so you have a lot of time to look at that. Please do all the lab homeworks and submit them. Submission of the lab homework is compulsory. It makes up 10% of your grade. So please do the lab homework and submit it online via stream. Of course, even if we have the videos online, feel free to ask me questions about the labs as well. We can also talk about the labs during the workshops or the review workshops. And yeah, if you're stuck or if you're confused about something with the labs, please feel free to talk to me about that as well. We've put up a face-to-face workshop, review workshop on campus. So we do recognize that social interaction is important. I mean, especially for students who have who's coming from school and whose studies have been interrupted, and you've always been doing online and you're fed up with online and you want to do face-to-face social interaction. So we've put up one face-to-face review workshops. For us at Albany, it's every week on Fridays from 1 to 3 p.m. The room is at QB5. This is not compulsory. So if you don't feel comfortable going, doing face-to-face, if you don't feel comfortable or if you're self-isolating, don't worry about these face-to-face workshops. What I intend to do in these review workshops is to go over the past workshops or lessons or the labs and reinforce anything that might need some clarification, or if you need more help with the lessons or the concepts, feel free to drop into the review workshop. So I view this as sort of like drop-in sessions. And if you cannot go to this face-to-face review workshops, but you really need some help with something, then please set an appointment with me and we can do our review workshop sort of virtually. Yeah, I guess the message I'm trying to get across is help is here if you need help. If you're stuck with something, please don't feel isolated. Please feel free to reach out. I'm always happy to help you. And then there's one online quiz, which we call Mastery Tests on Stream every fortnight. And that makes up 30% of your grade. So that's quite an important component of the course. It's also good to keep you on top of things as we learn lessons. We sort of assess you so that they don't pile up and then you're panicking towards the end during the exam. So the online quizzes that are run fortnightly are there to support your learning as we go along. So please do the Mastery Tests online quizzes. The first Mastery Test is already available on stream and it's due I think this Friday at the end of the week. But the first Mastery Test is not assessed, so it will not contribute towards your final grade. It's more like to get you familiar with the online system that we'll use for these online quizzes. So do check out the first Mastery Test, and if the questions are frustrating and you're sort of stuck and you don't know what to answer, don't worry about it. We'll go through those through the semester, and just try out the first Mastery Test, right? And then we have our two assessments, the semester test, which is around week 6. The exact date will be confirmed, but that's done online via stream. And that covers weeks 1 to 5. And then we have the final exam, which covers 40%, which is also done online via stream. And it covers pretty much the whole course. Notice that it's only from weeks 1 to 11 content. That's because in week 12, we've devoted that entire week to review the course and prepare you for the final exam. Yeah, and you can find all this info on stream. But if you have any questions, feel free to give a shout out. Right. Yeah. So for the drop-in session, we'll start that next week. Just so to get you started with the course and settled down. We'll have 2 lectures and 2 workshops this week, and then next week we'll probably have more content to look at in the drop-in sessions. But if you already want to ask questions, don't wait for the drop-in session next week. Ask them during the workshops, or send me an email, or set a time to meet me virtually, to ask your questions if you already have them. But then, yeah, the first drop-in session will start next week. All right. Well, good. Cool. All right, good. Okay, so let's get started with the content. We'll start this course by talking about objects that are moving. How do we describe an object that's moving? And hopefully at the end of this lesson, we will be able to be familiar with some terms like distance, displacement, speed, and velocity. There are quite 4 terms. Some of them are similar, some are very different. So at the end of the lesson, hopefully we'll know what's the difference between distance and displacement, for example, or speed and velocity. And then we'll also learn about units. What are units? Why are they important? Why do we use them? Right. So let's start with something familiar, which is measurement. We do measurement every day. We always check what time it is, right? Or if you go somewhere, you check how far this place is from your house, for example. So we're always doing measurements. We measure our weight, we measure how tall we are, our height, we measure time, temperature. But when we do a measurement, we always we state a number. So say I want to know how far the Massey University is from my house, and you look it up and say, oh, it's 10. Right, that's the quantity, it's 10. But just saying a number when you're measuring is useless, is meaningless, right? So if you say my house is 10 away from the university, it doesn't really make sense, right? What does 10 mean? Is it 10 kilometers or 10 meters, right? So when we do a measurement, we state the number, which we call the magnitude, but we also need to state a unit, which is the standard for which we are measuring that number against. So a physical quantity is a number resulting from a measurement. That's the number we quote. But that physical quantity is meaningless unless we state an appropriate unit. So when we say, I went to the supermarket and bought 5 apples. Okay. Sure, we say 5 apples, but it's still still not very clear whether we've bought 5 kilograms of apples, or 5 pieces of apples, or 5 baskets of apples. So unless we state the unit, the number we are saying doesn't really have much meaning. Okay. So in this course, especially, units are very important, and you will always be asked to specify a unit. Okay. What units to use are governed by what we call this System International, or SI units. These SI units, or System International, is the standard units that we will use. Okay. And there are 7 units which has this, there are 7 quantities which has these standard units. The most common one you'll encounter is the quantity of length. So when you're measuring length, the standard or SI unit that you will use is the meter, which has the symbol of M. When you're measuring mass or how heavy something is, you're specifying the unit for that measurement in terms of the kilograms, abbreviated by the symbol kg. And time, you specify that in seconds with the symbol S. Okay. So these first three quantities are the most common quantities that we will encounter in the first half of this course. Later on, when we'll talk about heat and temperature, then we'll need the units for temperature. The standard unit for that is Kelvin, which is quite different from what we're used to, the degrees Celsius. But we'll get there. We'll get to that in about week 7 or 8 when we'll talk about heat. And then we'll probably almost not encounter the last 3 quantities, but just for completeness, I put them here. All right. So these are the basic quantities: length, mass, time, with units meters, kilograms, and seconds. But sometimes we can combine these basic quantities and basic units, and we have what we call derived units. So derived units, these are units that are obtained by combining the basic units. For example, when we measure the area of something, we are multiplying 2 lengths. And so we end up multiplying the units of both lengths and come up with square meters or meters squared as the unit. So here, square meters is called a derived unit because you combine 2 base units. Okay. Speed, which we'll learn today, okay, is also a derived unit because you're combining. You will see later on that when you're measuring speed, you will combine the unit of length with the unit of time. So you have this unit of meters per second. You're combining 2 base units, meters and seconds, and therefore the unit for speed is a derived unit. All right, cool. Is everything okay so far with units? Okay. So then with the knowledge of the units, we are now in a good place to start describing how an object moves. Say, when this car moves from one point to another, we can describe how this object moved in terms of its distance and displacement, speed and velocity, and acceleration. For today, we'll first talk about distance and displacement. Okay, so when we say distance, it's how far an object is, how far an object has traveled, and that's measured along its actual path. And when we're measuring the distance, the direction does not matter. Whether the object went left or right, we don't care. We just want to know how far the object traveled in going from the starting point to the end point. And so the distance is always positive. Of course, the unit is in meters. So I'll introduce a terminology that we use when direction does not matter. When direction does not matter, we say that that quantity is a scalar quantity. And if your measurement is always positive because you don't care about the direction, that quantity we say is scalar. So for example, you have, as opposed to displacement, displacement is how far an object is from the starting point. And the main distinguishing feature of displacement is you have to put the direction. Did the object move left or right, or to the north or to the south? And in that sense, displacement can be negative. And the term we use to describe quantities that needs a direction is vector quantity. So when we say displacement is a vector, that means the direction is important. And so you need to include the direction in describing the displacement of the object. So let's just look at an illustration to understand these concepts. So say you have Homer Simpson, who's at Sylvia Park, and he wants to go to Britomart. He rides the train and goes through, you know, the route of the train from Sylvia Park to Britomart. If you wanted to measure the distance traveled by Homer Simpson, you would then measure the exact path that he traveled. So you measure the path from Sylvia Park to Panmure, from Panmure to Glen Innes, to Meadowbank to Orake, and so on, right? So following the exact path of the train. Okay? And so say the measurement you made was 16.9 and the unit for that is kilometers. So the distance traveled is 16.9 kilometers. On the other hand, if you wanted to find the displacement of Homer Simpson, you just want to know how far he is from the starting point. So in that case, with displacement, you're only concerned about the starting point. You're concerned only with the starting point and the end point. You don't care about the actual path that he took. Okay, he might very well took this path, drove his car and took this path, but you don't care about that path. When you're measuring the displacement, you just care about the final point, the end point, and the starting point. So in this case, you find the displacement by subtracting the starting point from the end point. Okay. Let's just say the displacement is 16.9 kilometers. Say displacement is less than, well, obviously we can see from this figure that the displacement is less than the distance, right? Okay. So you can also think of displacement as the shortest path that your object can take in going from the starting point to the final point, right? You also need a direction for this. So you can say the displacement is less than 16.9 kilometers in the direction of northeast or upwards or towards Britomart. Okay, so the direction you put can be arbitrary as long as you put a direction. That's the important thing for displacement. All right, any question about distance and displacement? Is that clear enough? Right? Okay, right. So say for example, you have this object, these two motions. You have the first motion, you have an object starting from this initial position, which is -3 meters in this number line. And that object traveled to the right, ending up at the position 4 meters. Okay, so the position is measured in meters. That's the unit there. Okay, and then you have a second movement, which starts from 4 meters and goes the opposite way. And ends up at -3 meter position. So what's the same about these two motions and what is different? Anyone? Yeah, very good. So same distance. Okay. Yeah, we can see here it's the same distance, the same amount of length that they traveled. Okay, very good. The distance is the same. What's different? Yeah, the displacement is different. Why is the displacement different? It's because the directions are different. Yes, very good. The direction is different. So yeah. So they have the same distance. It's both 7 meters going from -3, 1, 2, 3, 4, 5, 6, 7. Or if you subtract, the positions, that's 7 meters for the distance. Okay. Distance is the same, but the direction is different. Therefore, the displacement is different. Right, so displacement, mathematically, yeah, we've been doing that. It's the change in position. So displacement, we use the symbol delta x for displacement. For distance, we'll just use the symbol d to differentiate those two. And delta x, the delta here just means change. So delta, this symbol, Greek symbol delta, means change. So delta x therefore means change in position. And we can calculate that by subtracting the initial position xi from the final position xf, right? Okay, so some notes about displacement. So the displacement delta x, final position minus the initial position. It can be positive, negative, or zero. Okay. Right? Because direction is important, but the direction is arbitrary. The convention we will use is if we say the movement is to the right or to the east or positive x-axis, we'll say that that's positive displacement. Upwards or plus y north, that will also be positive displacement. When the movement is to the left or to the west, negative x, or downwards, then we say that the displacement is negative. So this will be the convention that we will use in this course. So say, for example, so let's see, when will the displacement be positive, negative, and zero? So let's consider this figure here, this case. The object started from 10 meters, position x1, and it moved to the right, ending up at 30 meters, position x2. What is the displacement of this object? Yeah, 20 meters. Yeah, good. To the right, positive 20 meters. That's very good. Okay, right. So the displacement in this case is positive. We can see here the object is moving to the right by this arrow. You can also work that out using this equation. So the final position is 30 meters minus the initial position, which is 10, right? 20 meters. Okay, from subtracting a bigger number, a smaller number from a bigger number, you automatically have a positive result, which gives you the positive displacement. Okay. So when we say 20 meters, that's understood that it's positive, and the direction is positive or to the right. Okay, good, very good. So how about this movement going from 30 meters to 10 meters? What's the displacement in this case? Negative 20 meters, very good, right? So we can see the displacement is to the left, okay, right? And we're subtracting a bigger number from the smaller number. So if you say 10 minus 30, will give you a negative 20 meters displacement. Okay? That then considers the negative sign, means that the direction is to the left, which is the convention we've indicated. Okay? So the negative sign sort of gives you the direction for the displacement as well. Good. All right. When will the displacement be zero? Because displacement can be positive, negative, or zero. When will it be zero? Yeah, very good. Yeah. So here, when the starting point and the end points are the same, then you're subtracting the same number. You're going back to your original position. That's when the displacement is zero. Okay. Good. All right, so just a little exercise. Try this out. You have here an object that starts at point A. It goes to point B, to point C, point D, point E, and finally ending at point F. Okay. We've plotted in this graph the movement of this object. So one grid along the horizontal is 2 meters. Okay. The unit of the horizontal axis is meters. Okay, one grid is 2 meters along the horizontal, and one grid along the vertical is also 2 meters. So find the total displacement and the total distance of the object. I'll give you a few minutes to sort of think about this problem and sort of figure out how to get the displacement and the distance. Yep. Good. All right. So let's look at the answer here. So let's look at the this displacement first. So displacement, you're just going from the starting and end positions. You're just concerned about those two. So starting at position A and ending at position F. Okay? And the object went from position A to position F upwards. Right. Okay, so if we measure the length of this arrow going upwards, then you have 2, 4, 6, 8, because each grid is 2 meters. So you're going 2, 4, 6, 8 meters, and the object moved upwards. So we can say that the displacement is 8 meters and the direction is upwards, right? Okay, and for the distance you have to consider each path that the object took in arriving to the final position. So the object went from point A to point B. So for this path there, again, each grid is 2 meters. So from point A to point B, that's 2, 4, 6, 8 meters. Okay, and then so that's that 8 meters in that equation. And then going from point B to point C is another 8 meters. Point C to point D is 4 meters. And for this diagonal distance, you're given that diagonal distance is 5.7 meters. And then finally, going from point E to point F is 4 meters. Add that all up. Okay, so when with distance, everything's positive. So you're just adding positive numbers. You have 29.7 meters for the distance, and you don't have to put a direction. Right? Good. Any question about the solution? Right. Okay. Then we'll move to speed and velocity. Okay, so what is speed and velocity? Right. So speed, we sort of have an idea probably that speed is how fast an object is moving. Right. When we drive our car, we sort of see the speed is 100 kph. The speed limit is 50 kph or kilometers per hour. So we sort of have this concept of what speed is. So let's just formally define what speed is and put that in an equation that we can use to work on problems for. So to define speed formally, let's talk about a time interval first. So time interval is how long the object takes to cover a certain distance. Okay. Yeah, it's final time minus the initial time. We'll use the symbol delta t again. Delta means change change. So that's the change in time, meaning, yeah, you can just think of it as the time interval, the time it took for the object to cover a certain distance. Usually, we take the initial time to be 0 unless it's stated otherwise. And in this case, when you see the symbol delta t changing to just t, that still means time interval. It's just that the initial time is 0. And we know that time is always positive. It's always moving forwards. We cannot bring back time. And there's no sense of direction. So time is a scalar quantity. We'll use seconds as the standard or SI unit. So when we say speed, it's then the distance. So how fast an object is moving. That's essentially what speed is. Formally, it's defined as the distance traveled by the object divided by the time it took to cover that distance. Okay? So it's distance covered divided by the time interval, or the time it took to cover that distance. In equation form, we have speed. Okay? So I'm using here average speed because we're talking about a time interval. Later on, we'll talk about an instantaneous speed. But essentially, when we say speed, we are talking about average speed, unless we specify specifically instantaneous speed. When we just say speed, it's average speed, which is distance divided by the time interval. If we work out the units for speed, we substitute the units for the quantities in this equation. The unit for distance is meter, and the unit for time is seconds. Therefore, the unit for speed is meters divided by seconds. And sometimes we write this notation, meters divided by seconds, can be written as meters times seconds raised to the power of -1. So these are just equivalent notations that you might encounter as ways for writing the units for speed. Just know that these are equivalent and the same. All right, so that's speed. Because distance is a scalar quantity, we don't care about the direction. It follows then that speed is also a scalar quantity. We don't care about the direction, and therefore speed will always be positive. Right, so say you have this, you say, for example, you're starting at a -3 meter position, and you're moving to the right, ending up at the +4 meter position. Say you have a stopwatch. Okay? You've started the stopwatch, the timer started to run, but you only started to move when the timer reached 9 seconds. Okay? So that's the initial time for when you've started moving. Okay, and then you reach your final destination 4 meters, at the position 4 meters, stop the stopwatch and saw that the time was 14.75 seconds. So, and you wanted to find the average speed of your movement. How will you find what is the average speed of your movement in this case? Right, so as usual with questions like this, I'll give you some time to think about the problem and maybe work out the solutions, and then we'll look at the answer. Okay, right, so there's already an answer on in the chat box there. So let's look at the solution. So average speed, you need to find the distance and then divide that with the time interval. Right, so you're going from -3 meters to 4 meters. So that's a distance of 1, 2, 3, 4, 5, 6, 7 meters. And the time interval is the final time minus the initial time. In this case, the initial time is not 0. So we therefore have to consider this 9 seconds initial time to find the the time interval. So that will be the final time minus the initial time, which is then 5.75 seconds. Okay. Right. So if the initial time was not given to be 9 seconds, then you can assume that it's 0 seconds. But in this case, the initial time was given to be 9 seconds. Therefore, when you're finding the time interval, you'll need to subtract the initial time from the final time. Right. And so the average speed is 7 divided by 5.75. That will give you 1.21739 blah, 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 blah meters per second, which we round off to 1.22 meters per second. Yeah. So some correct answers in the chat there, which is great. Okay. Right. You're probably wondering, like, how will you round this number when you're doing a calculation? How many decimal places should you round your answer to? And that's a very good question, right? The mastery tests, they're often multiple choice, in which case it's not important the number of decimal places you'll enter as your answer, but sometimes we'll ask you to enter your answer, and in that case it will be useful to know how many decimal places you enter your answer in the mastery test question. So the rule we'll follow for rounding numbers is called the significant figures. So when we're doing calculations, we round the final answer to the least number of significant figures. And this slide just lists down some rules about significant figures. Significant figures, it's the number of digits that carry meaning. For example, all non-zero digits are significant. So if you write 6.43 meters, that's 3 significant figures. Okay, so we round, we round the final answer to the least number of significant figures given in the problem. And so you're welcome, of course, to look through this slide to determine whether that number is significant or not. Okay, so so zeros, so here zeros after a decimal point, they are significant. Okay, so let's look at our problem here. 9.00 seconds. How many significant figures does this have? Okay. This has 3 significant figures. Right? The zeros after the decimal point are significant. So 3.00, that also has 3 significant figures. 14.75, so all non-zero numbers are significant. So in this case, this has 4 significant figures, and 4.00 has 3 significant figures. Okay. So we can see in the given information, the least number of significant figures is 3. Therefore, in our final answer, we round that to 3 significant figures. Okay. All right. Any question about that? Yeah, you can always refer to this slide for significant figures, because all the tests and exams are open book and open notes. So you don't have to memorize these rules for significant figures or the equations either. You can always refer to the lecture slides or your notes. Okay, right. So let's now go to velocity, average velocity. How is it different to speed? So average velocity is defined as the displacement divided by the time it took to cover that displacement. Okay. So essentially, the only difference is that instead of using distance, which you used for speed, you're now using displacement. So when you're looking for velocity, you need to use displacement. And the equation for that, putting that in equation, it's displacement divided by time. So it follows that because displacement is a vector quantity, velocity is also a vector quantity, and the direction is important. Okay. The unit is also meters per second. Okay. It's the same as the unit for speed. Okay. So here, let's go back to our example. You're again starting from the initial position, -3 meters, and this time you're actually starting from the right. Initial position is 4 meters, and you're actually moving to the left with the final position of -3 meters. Again, you started the walking. You started walking when the after you've put the timer on, and you've started walking at 4.68 seconds. Stopped walking at 10 seconds. What's the average velocity of your movement? Right. Okay, make sure when you're doing velocity, make sure you have a direction. You're indicating the direction. The direction can be indicated by a plus or minus in your final answer, or an explicit direction of like to the left or to the west, or some direction. All right, so the average velocity, we need to find the displacement delta x, and we need to divide that by the time interval delta t. Right. So the displacement, your displacement is the final position minus the initial position. So here now it's important to include the sign in your positions. So you're ending up at -3 meters. So you have to include the negative in your calculation of the displacement. Okay, and you have the minus sign, which is this one, minus the initial position, which is 4 meters. Your initial position is positive, and therefore you have a positive 4 meters here. So overall, your displacement will be -7 meters. The negative sign is important there because the negative sign indicates the direction, which is to the left. So yeah, time interval, it's the final time, which is 10 seconds minus the initial time, 4.68 seconds. The time is always positive, so don't worry about any directions or anything. And then the average velocity will be your displacement divided by time. Again, you have to include the sign in your displacement because that carries information about the direction. So here you still have the negative in your displacement, and you have the positive time. So you'll end up with a negative average velocity, -1.3 meters per second. Okay. The least number of significant figures is 2, and therefore I round my answer to 2 significant figures. The negative sign here means that you're moving to the left, and so the direction is to the left. So you can also say that your answer is 1.3 meters per second to the left. That's also a correct answer. Okay, even if your 1.3 is positive, but by saying that it's to the left, you have the explicit direction stated there, which is required when you're doing velocity. Right, good. Okay. All right, any question about that? Average speed and average velocity? Okay. Right, okay. I'd take silence means no question, and we can move on. Right, so here's a conceptual question. So the fastest marathon runner, Jeffrey Mutai, can run 2 times around a track and field oval in 40 seconds. What's his average speed and what's his average velocity? In one round, in a track and field oval is 400 meters, and he does 2 rounds in 40 seconds. Okay, so try to figure out what's his average speed and what's his average velocity. All right, so just for easy reference, here are our equations, right? For speed, you have this: speed is distance over time, and velocity is displacement over time interval. Right, so I can see a correct answer there in the chat box already. So let's look at the solution for this. Let's do the average speed first. Okay, so we need to figure out the distance that he has traveled. He traveled the track and field oval twice, and one round is 400 meters. Therefore, his distance will be 2 times 400 meters. Right? So his distance will be twice around the track and field oval. Okay. So you have there the distance 2 times 400, and he travels that distance in 40 seconds. Okay, punching in your calculator, that will give you 20 meters per second. Yeah, when I was teaching this course in previous years, there's sometimes an issue with the equation was set up correctly, but when you enter your answers in the calculator, you get a different number. It depends on there are different kinds of calculators, and it depends on your calculator. Some calculators are quite picky. You might need to put a bracket in your calculator. So if you're not getting 20 meters per second, but your equation is correct, you might want to put a bracket when you're entering your numbers in your calculator. And that might be the problem. But if you're still not getting 20 meters per second, yes, feel free to talk to me, and we'll sort out how you enter numbers in your calculator. Right, so average speed is 20 meters per second, and I can see there very good, the average velocity is 0. It's essentially because if he's running around the track and field oval, his starting point will be his finishing point. Right. Yeah, we're assuming that he's not running through this. Because sometimes if you're doing a 800-meter race, the runners are staggered along the track. So the assumption here is he's ending at his starting position, and therefore his displacement is 0, and that gives him an average velocity of 0 around the track and field oval. Okay, so we can see there how speed is different from displacement. Okay. Okay, so average speed takes into account the total distance, whereas average velocity takes into account the total displacement. Right, so we've been talking about average speed and average velocity, okay, taking considering the time interval, but sometimes we want to find instantaneous speed and instantaneous velocity. Okay, so instantaneous speed, it comes here. There's a clue here. Instantaneous means instant. So when we say instantaneous speed, it's essentially the speed at a specific instant of time, at an instant of time or specific time. And instantaneous velocity, therefore, will be the velocity at a specific time, or the velocity at a particular instant of time. So it's a single time. That the connection disappeared. So let me find out. Yeah, okay, good. So it's only a single time that you want the speed or velocity for. It's not the time interval. A very good example of this is your speed the moment you look at your speedometer. So when you're driving your car and you want to check your speed, you glance at your speedometer and you see you're moving at 50 kilometers per hour, then that will be your instantaneous speed, because that's your speed at the particular instant of time that you've looked at your speedometer. Okay? right? So that's the difference between average speed and instantaneous speed. Average speed, you're looking at the time interval, how fast you were moving over this time interval. Whereas for instantaneous speed, it's how fast you're going at this particular instant of time, at this specific time. Okay. Yeah. All right. Does that sound sensible? Does that sound all right for instantaneous speed and velocity? Good, right? I can see some thumbs up. Good. All right. So then that essentially wraps up our discussion in this first lecture, talking about this distance, displacement, speed, and velocity, and units. So if you have any questions, feel free to ask them. Pop your questions in the chat box, or raise your hand, or talk directly. Yeah, but if there are no questions, we'll have maybe a 5 or 10-minute break, and then we'll do the workshop. Yeah, I'll stop the recording now. I'll stop the share, and I'll stop the recording.